Hello, Geography 231 students. Welcome to your final tutorial of the fall semester and your final tutorial of Geography 231. So we've made it this far, and if you are a former Geography 232 student, if you took my class last spring, you've come full circle because we're back at raster data, okay? If you haven't taken 232 yet, this is going to be some new material. So make sure that you're watching this after you already read and watched the lecture. Okay, this is a tutorial video. So this is going to be new for some of you, review for others. So obviously that's the challenge of allowing the 231 students to take 232 first, is that not everybody's on the exact same page, but obviously this will serve as a great introduction if you haven't already taken 232. This is really just a good way to get your feet wet in raster data, and you're going to learn not just how to work with raster data, you're going to learn a few concepts that are going to come in handy when you do take 232, like map algebra and image classification, and you're going to refamiliarize yourself with the Making Spatial Decisions using ArcGIS Pro textbook, right? So it's been quite a few weeks since we cracked this baby open, so welcome back to the book. Okay, so first thing we're going to need to do is download the data. All right, so we haven't actually had to do this for the last few weeks because I've been uploading the data to Canvas, but in this case you actually have to go onto arcgis.com. Just type that into your browser, and then you're going to want to log in, so go ahead and click sign in. And if at any time you need to pause the video, go ahead and do so. You're going to log in with your same credentials that you were assigned at the beginning of the semester. Your screen is going to look different than mine, but the thing that you need to know is there's a search button up there. No matter whether you're a student or a professor, you still have the search button. So the thing you're going to do, the textbook tells you to search for, and so we're going to do Esri Press, no underscore, Esri Press underscore MSD for Making Spatial Decisions. ArcGIS, go ahead and hit enter, and you're going to get no items found. Not to worry. First, change this to groups. Next, uncheck only search in Cypress College, and you should get one search result, which is always handy when it's just one because you don't have to filter through others. All right, so this is Karen and Colvord are the authors of the textbook, and we want the Hurricane Katrina data set, which you actually have to click show more to get that. So Katrina data, don't click the actual name, that'll just tell you more about the data set. What you want to do is click the three dots here, download, okay? And I've actually already downloaded it, so I already have it in my downloads. Go ahead and do that now. And then once it's downloaded, you can pause the video as needed. I'm gonna go ahead and open up ArcGIS Pro, and we're gonna go start without a template. And right off the bat, we're going to go project, save as, and you are going to save it into your class folder, wherever you're saving your material on your machine. And you're going to save it as Katrina results. Katrina underscore results. And save. Okay, once you've saved, now you need to extract the package that you just downloaded from arcgis.com. So go ahead and click on the Analysis tab, Tools, and do a search for Extract Package. It's the Extract Package Data Management tool. Browse to the Downloads folder on your machine, most likely. Output folder, save it in the folder where when you save this project, it automatically creates a folder, so you just have to go navigate to where you saved your project. I'm just going to save it into there, raster, week 14 raster, and then run. Okay, once it's done, click on the Catalog tab, Go ahead and maximize your folders. It looks like we have to connect to the folder to make sure we can access all of the data. So right click on folders, add folder connection, navigate to where you extracted the package, and P13. For whatever reason, they always use P13 to indicate where the data is saved. All right. So once you've got that folder connection to P13, maximize it, look for katrina.gdb, and within there you're going to see a layers feature dataset and 2 raster files called elevation and land cover. You need to make sure you have a map actually, so let's make sure we create a map. Right off the bat, we need a map, so map, insert tab, new map. Okay, and then you can click, drag, and drop the entire layers feature data set onto your map. Drag and drop, it's going to add all of the layers. You actually don't need all of these turned on, so what you should do is select the first one, scroll down until you get to the last layer above topographic, hold down Shift and click to select all of them, and then hold down Control and check any of them to turn them all off. And while they're still selected, also click the little expand collapse button, hold Control and click one of those to collapse them, just to save some space on your screen. All right. Okay, and then before we move on from adding data, we're also going to drag in elevation raster, which might take a little bit of time. That didn't take long. And land cover. Okay, and you can turn those off as well. All right. So we've got our data in there. Before we turn any layers on, first thing we're going to do is save our project so we don't lose the work that we've already done. And then we are going to right-click on the map name here, the data frame, properties, and we're going to check out the coordinate system. Let's see what it is. So the book wants you to kind of familiarize yourself with various coordinate systems. It's just a good habit to get into. So when you see one, you can at least, you may not know exactly what the projection is, but you'll have kind of you'll have familiarity with it when you see the name, the projection. So go ahead and click on coordinate systems and then view it there. So it is North America Albers equal area conic. North America Albers equal area conic is a very common projection when you're looking at the continental United States. Okay. It also works for Canada as well. Basically, the whole continental U.S., the distortion that is inherent in any projection is fairly dispersed across the whole continent, so that, you know, Oregon looks fairly natural, as does Maine, as does Florida, and as does California. So it's a nice kind of compromise projection. Okay, so you can close that and then move on to the next page. We are also going to set environment settings. Okay, environment settings are important because they allow you to really save time in the future. Okay, so what I mean is that you essentially can choose the default geodatabase, Scratch working database. Also, when you're working with raster data, you can essentially preset a mask that will clip the raster file. So oftentimes, I'll just kind of give you an example. If you turn on the elevation raster and zoom to it, it covers a fairly large area, but we're actually only concerned with the area that happens to fall within the counties layer. All right, so all of this extra raster data we don't need. So we're not going to clip it, but when we are going to run some geoprocessing tools, we're going to create a new raster, and that will only have the area that falls within the counties. Okay, so that's why we set environment settings. So let's go ahead and do that now. Analysis tab, environments. We've got our default geodatabase. In your book, it's going to say Katrina results.gdb, and I think the order of things is a little bit different the way I did it, but it's actually not a big deal. So you can leave those as is. For the output coordinate system, go ahead and hit the drop down and just do current map. So any new layers that are created will have the same coordinate system as the map that we're working in. All right, next thing we need to do is processing extent. Change that to counties so that all geoprocessing is limited to the counties mask. And then next up, we also want to set the processing extent, the cell size rather, for raster analysis. We're going to change this to same as elevation. So raster analysis, cell size, same as elevation. And then mask. We're going to do mask, change that to counties. All right, so that will guarantee that any output raster layers that we create are in the shape, essentially like a cookie cutter shape of the counties layer. And go ahead and hit OK. And now that that's done, save your map again, just to be safe. And then you can skip the create a process summary for now. Essentially, that just is encouraging you to kind of keep notes of what you do. And you don't need to do that for this lab, but in the process of working on your projects, very important to take notes. So it is something just to keep in the back of your minds whenever you engage in any kind of geospatial analysis. Make sure you are keeping tabs along the way so that you can document the steps. If it comes down to a question of your methodology, you can say, all right, well, at this step, I did this or that or the other, and you don't have to kind of recall. Okay. All right, so once you've examined the data and set the environments, you are ready to begin the analysis and to prepare the displays to address the flooding problem. So I probably should explain, what is it that we're doing? We are sitting in the role of GIS analysts or specialists looking at the damage done by Hurricane Katrina. Hurricane Katrina, which I'm sure most of you know, was one of, if not the most destructive hurricanes to hit the United States, at least in the last century. Okay, so it hit in 2005. New Orleans is a city that obviously had some probably the longest, I guess you could say, repercussions from the hurricane, but also the actual hurricane track itself tracked pretty much right between Louisiana and Mississippi. So Mississippi didn't get as much press coverage because it didn't have the big city like New Orleans, but Mississippi was equally, essentially the coastal areas were destroyed, right? So what we're going to do is we're going to look at the areas that were flooded. Okay, so this is going to do what rasters do really well, which is every single cell in a raster file, you'll know this if you've already gone through the lecture, represents some numerical value. In this case, it's going to be storm surge elevation, okay, the height of the water. So we're going to be able to know how high was the water. We're going to take a raster file such as the elevation layer you're looking at, and each one of these pixels represents an elevation. So if we know the storm surged 15 feet, or about 3 meters above mean sea level, we can then do an overlay and say that any pixels or any land cover that happened to be below 15 feet above mean sea level was inundated, was underwater. So that's more or less the gist of what we're doing. There's a few more other steps as well. Okay, so anyway, back to where we're at. So deliverable 1, we're going to create a map showing the elevation and the bathymetry. Okay, bathymetry is basically the shape, the topography of the seafloor. Okay, so a map showing the elevation and bathymetry of the Mississippi coastal counties with places, types of water, streams, creeks, whatever, barrier islands, rivers, and a time series showing Katrina's track. So the track that Hurricane Katrina took. Okay. All right, so all your layers are already off. So we're now, well, except for elevation, we can actually turn off elevation for now. We're going to turn on counties and then zoom to layer, which I already have done. Okay, so go ahead and do that. And then we're going to label the counties. So you can do it quickly. You right click and check label. But when you do that, the GIS doesn't know which field in the county's layers attributes it should draw the label from. So you always need to go ahead and click on the labeling tab up here and make sure that the field is set to an appropriate field. In this case, it's county. So now we have Hancock County, Harrison County, and Jackson County. Okay. And now we're going to change the symbology for county, so make sure it remains selected. Click on the Appearance tab, and then click on Symbology. You can leave it as single symbol. Check the color square there. Go to Properties, Color, No Color, Outline Color, Red of your choice. I usually go with Mars Red. And then we're going to make it 2-point thickness and hit Apply. All right, so we have outlines, we have labels. Next thing we are going to do is symbolize the places layer. So go ahead and turn on places. And then we're going to change the symbology for places to diamond. Diamond 1 specifically is the template we're going to use. So make sure that places is selected. Click on symbology, click on gallery, then do a search for diamond 1. And just go ahead and check that. You don't have to change the size or anything, just leave it as is. Next up, we're going to change the symbology for rivers. So go ahead and turn on rivers and make sure it remains selected. And then keep it a single symbol. Click on the template there. Properties, we're going to give it a kind of a lighter blue. We'll go with Yogo blue. And we'll leave it as 1-point font. Hit apply. All right, so it makes it kind of a blue that's not too overbearing, but also not too light. Next up, we're going to turn on water. And we are going to go to symbology for water. In this case, we're going to change it for water. We're going to change it from single symbol to unique values. And the unique value that we're interested in is F-type. F-type has to do with the type of water, type of body of water. So we've got canals, lakes, ponds, reservoirs, streams, rivers, swamps, and marshes. Okay, so you can see a lot of swamps and marshes there along the coast. Go ahead and, this is a step we haven't done yet this semester. You're going to click on the color scheme, and then click on Format Color Scheme. And this is actually a little bit different than the book actually says, and I think that there's must have been an update to the program. But we're going to change it from random color scheme to continuous color scheme. All right, and then on the left-hand side, we're going to make this light blue. I'm going to go with Sugar Light Sky, and then click on the little color square there. There we go. Make that Sugar Light Blue. Then click the one on the right. There we go, and change that to a dark blue, like Ultra Blue. Okay, and hit OK. There we go. All right, so basically it just uses a color ramp from light blue to dark blue for each of the various bodies of water. And then before we move on from that, click on More and uncheck Show All Values. So if there are any values that don't have a name, they will not be labeled. Okay. All right, go ahead and save your map, or your project rather. And then you can close the symbology pane for now. Next thing we're going to do is turn on islands, which are actually already visible here via the water bodies, but we actually want to turn on the land that makes up the islands. Let's move the islands layer above water, so it'll show. And then we're going to change the color, and you can hit the little expand collapse button, expand it. Click on the modify color symbol and change it to a light green. I'll go with olivine. Oh, that's yellow. Never mind. Savorite green. There we go. Then hit apply. And then before we move on from islands, we are going to actually, you know what? I'm going to skip. No, I can't skip. I don't want to skip a step. Never mind. We are going to label them as the book says. I'm not going to freestyle. Okay. So right click islands. Label, and in this case here, it draws the label from the name field, and it gets it right the first time, which is handy. But what the textbook wants you to do is remove the word island from each feature name in the attribute table, so that instead of saying cat island, ship island, horn island, it's just cat, ship, horn. I don't think this is entirely relevant to the lab, but I don't want to jump around. So go ahead and open up the attribute table for islands, and then under the name field, double click the first cell and just get rid of the word island for that one. Do the same for the next, and the next, and the next. Okay, and then before we move on, go to the Edits tab and then click Save. And that's going to save the edits that you make to your attribute data. Okay, and then return to the Labeling tab and change the text symbol from regular to bold to make it stand out a bit. All right, okay, save your map once again. Save early, save often, as we always say. We can close the attributes here, close the attribute table, close the symbology pane. And then we are now going to change the base map here from just the standard default map to a base map called Oceans, for obvious reasons, I think, right? Okay, so you can't really, it doesn't look much different until you pan out or zoom out a little bit, and you can actually see it shows the bathymetry off, within the Gulf of Mexico and everything. But the continental shelf stretches so far out into the Gulf of Mexico that you really can't tell much there. Much unique. There's not much unique going on. Okay. Next thing we're going to do is turn on the Hurricane Katrina storm track, and we're going to symbolize it to basically indicate where the pressure was the most intense. So obviously a storm system is a very, very low pressure system. And so what we're going to do is we're going to symbolize based off of the Hurricane Katrina's storm tracks pressure value. Okay. So go ahead and turn on Katrina track, and then right click and zoom to layer so you can actually see it. All right, so we can see the track starts, obviously the hurricane didn't start here, but this data set starts here over the Bahamas. It heads to the northwest, crosses the southern tip of Florida, goes back out into the Gulf of Mexico, then takes this hard right to the north and passes right over the border between Louisiana and Mississippi. Okay, so keep Katrina track selected, click on the Appearance tab, and then we're going to click Symbology, change this from single symbol to graduated colors. And then the field is going to come from the pressure field, as I mentioned before. So you can see that the lowest pressure will be a color of our choosing. We're going to leave it as pressure, natural breaks, 5 classes, and then change the color from the whatever the default is to yellow to red. Yellow to red 5 classes. I think it's called, what's it, yellow? You know what? Turn on show names. Do as I do, not as I say. All right, so yellow to red 5 classes. Where are you? There we go. Yellow, orange, red. All right, so we can see at the lowest pressure, 923 millibars there, it's passing right over this the coastal area of the southern United States. It's kind of hard to see at this fine thickness, so we are going to make it thicker. So click on the More tab, Format All Symbols, and up this to 5 points and hit Apply. Now we can actually make it out a bit better. Okay, so you can see the pressure is relatively high over the Bahamas, and then it dips down, it intensifies. The storm essentially intensifies as the pressure drops, or I should say the pressure drops and the storm intensifies. And then as it heads north inland, obviously the pressure rises and the storm de-intensifies, starts to calm. It becomes a tropical storm, then a tropical depression, and then it just dissipates into bad weather over the northeast coast. All right, so now we're going to enable the time variables here. So some data have a time attribute associated with them, not all, but if you do find data with a time attribute, it's actually really useful and you can do a lot with it. Like you can actually create an animation, which is what we're going to do. Okay, so make sure that Katrina track is selected, and then right click, properties, and then click on time. All right, so by default, it says no time. We're going to change that to each feature has a single time field. And then the time field is time 2 down here. And then the rest can remain as a default. Hit OK. And when you do that, you'll then notice, and you may not notice actually right off the bat because it's fairly transparent, but you'll see that if you look closely, there is now a time slider here. All right. And so if you hit play, you see that over each of these various segments, it represents a various point in time, and it looks like they're moving in 6-hour steps from whenever it starts, August 23rd, 2005, through August 31st, 2005. And so on right around August 29th is when it makes landfall, and then it just heads directly more or less northeast, and then, as I said earlier, dissipates over the interior of the United States. Okay. All right, so we've played it, we checked it out, you now get to see what it does, and then you can sort of tweak it a little bit. So go ahead and click on the Time tab. As long as you still have Katrina track selected or highlighted, click on the Time tab here, which is a contextual tab. And because this data set represents a period of 18 days, we're going to change the number of steps to 18, so that instead of moving in 6-hour increments, it now moves in basically 1-day increments. Okay. And then we're going to move the speed to right around 75%. so it's a little bit slower. Okay, and now let's play it again. So we basically have the 23rd, 24th, 25th. Looks like it's actually about 2 per day now. At any rate, it works out into basically 18 steps. Okay, so that's what we can do. So save your map when that's all done running, and then I want you to pay attention to this Q4, question 4, and I'm actually going to kind of rephrase it just a little bit for the assignment, but this is going to be one of the deliverables I'm going to ask you about. Write an analysis describing the variables and their interrelationships. For example, how does hurricane wind speed vary based on location over land or water, or how does hurricane pressure vary with depth of water? Refer to your map as you compose your analysis. What I want you to do, and I'll rephrase it on Canvas, but basically consider the role of pressure. Okay, so the role of the millibars that you're looking at in the attribute table, and also knowing what we know about Hurricane Katrina as it made landfall. It was very intense. How does pressure how is it interrelated with wind speed and with essentially destructive power? Okay, so just something to keep in mind and think about that now. Okay, next thing we're going to do is deliverable 2. Deliverable 2, and then after the next couple of pages here, I'm going to walk you through the point where we will do essentially a classification of a raster image, and then I'll let you finish the rest on your own. Okay, so deliverable 2 is a map of flooded Mississippi coast after Hurricane Katrina. The map should include a table showing the percentage of total flooded land and acreage of land by land cover type. All right, so this is going to be one that you're going to need to turn in. All right, so what we're going to do now is move on to the quantitative analysis portion of this project, and in order to do so, we're going to make a new map. Okay, we're going to do new map so that we can sort of, we're going to not start fresh. We're going to keep everything that we've already done, but we can kind of freeze this as a moment in time and then move forward. So in the catalog pane, click on the expand button there for maps. First, let's change the name from map to flooded land. Oh, I'm sorry, Hurricane Katrina. Hurricane Katrina, because that's what we were just looking at, right? And now we're going to right-click Hurricane Katrina, copy, and right-click maps, paste. So it makes a copy of Hurricane Katrina. We're going to change the name of this to flooded land. All right, so we've made the copy. Now we need to open the map. So go ahead and double-click flooded land. There it is. It's going to look more or less the same, although apparently it's zoomed out a bit. So let's go ahead and right-click on counties, zoom to layers, so we can get back to more or less back to where we were before. And then let's turn off a few layers. So we can turn off the Katrina track. We can turn off places. Where is that? Places, rivers, and water. So we just now have on the counties and the islands. Okay. All right. So we added the elevation raster at the beginning, and so we're going to return to that. So let's move. Well, I guess let's first turn on elevation, so you can see it. There we go. And we can leave it. We'll leave it here for. The book says to move it above counties, but I don't think we need to do that. We'll leave that there. Leave it where it's at. But one thing we need to do is we need to find out what the map units are. So when we talk about rasters, as I said before, every cell represents some numerical value. But what do those values actually represent? We know it's elevation, but what are the units? Is it inches, feet, meters, miles, right? So it's obviously, you can probably intuit, it's probably either meters or feet. So let's find out. So right-click elevation, go to properties, and then click on the elevation tab here on the left, and look at the bottom, elevation units, meters. So there are a few things you could do. You could actually change this to feet, but we're not going to do that. We're going to leave it as meters. Then we're going to do essentially a times, like multiplication. We're going to use math to multiply these numerical values by the conversion rate from meters to feet, which is about 3.28 feet in a meter. And there's actually a tool for that. So let's do that now. So go ahead and click on the Analysis tab, Tools, which will bring up the geoprocessing pane, and do a search for times. I feel like there's probably a less vague sounding name for this. We could call it multiplication, but they call it times. And specifically, we want the times option for 3D Analyst. Okay, so go ahead and click on Times for 3D Analyst. And we are now going to the input raster 1, select the layer, elevation. And then what you can do is multiply one layer by another layer, or a field from another layer, but we're actually just going to put in an actual value. So it's going to take the elevation data from the elevation layer and multiply it by 3.28. Okay, so 3.28 feet to meter. And then we have to choose our output layer name, which will be elevation underscore ft for feet. And then let it run. Oh, there we go. Okay, so far it looks the same, right? As I mentioned earlier, it should be clipped to the counties layer. Well, it is, but we still have the original elevation layer on. So let's turn off the original elevation layer. And now we can see the new one, which has now been converted from meters to feet, is also nicely cropped to the shape of the counties layer, the 3 counties. All right, so I think that's a really handy feature or function of setting environment settings. You end up creating new layers, and they actually are the shape of the features that you want them to be. So that's great. All right, so we did that. Let's save our map, and then we are going to symbolize our new layer. All right, so there are different options for symbolizing raster data that are not available with vector data. And so let me show you that. So make sure that elevation FT or feet layer is selected. Click on appearance, and then for symbology, hit the drop down. You know, notice it's not just the unique values or what do you call it? Graduated symbols, graduated colors. It's stretch, discrete, classify, unique values. There's that vector field. All right, so we actually are going to click on classify. And notice it says assigns a color for each group of values. Okay. So classification is like a whole field unto itself that you will get into in 232, or you already got into last semester. You know all about image classification, hopefully. But basically, image classification allows you to take a continuous raster, which you should have learned in this week's lecture that rasters can be continuous or discrete. Continuous data means the values are continually changing from cell to cell. So the odds of 2 cells being adjacent to one or having the same value is very low in a continuous raster, because essentially you're looking at like an image, like a photograph. And so, as we know, the landscape changes from place to place, and so the chances of an image sensor looking at and receiving the same numerical value, or this is sensing the same data from one point to the next, is pretty low, because it's looking at grasses which vary, and concrete and trees and water. Whereas with discrete features, essentially all of those continuous numerical values are reclassified so that they fall into some specified number of classes. So instead of a continuous, virtually unlimited number of values, you actually can say 5 different classes or 10 different classes. So that's essentially what we've done. We haven't actually reclassified. We've kind of simulated classification by using this classify symbology tool. And so we now have 5 classes from yellow to red, but this is not really what you would really associate with land cover, right? So let's change this color scheme to, it's actually called elevation 2. All right, so make sure the show names is selected. Then we're going to scroll down, and they're in alphabetical order when you click show names. Scroll down until you see elevation 2. Now it's starting to kind of resemble what you would associate with elevation. Greens for lower elevation, whites for the snow in the mountains, right? Obviously there's no snow along the Gulf Coast, but still your mind sees those colors and you kind of associate it with elevation change. Okay. All right, so we've done that. We will now isolate the parts of this raster that were inundated with water. Okay, to do that, we essentially are going to run what's known as a Boolean operator. I talked about it in this week's lecture. Boolean operators basically are yes/no binary values. If they meet the criteria, then yes. If they do not, then no. So if they meet the criteria, 1. If they don't, 0. It's binary. Okay, you still have to choose the criteria, which you are going to do in a moment. Okay, so the next step is to isolate the area flooded by the storm surge of 15 feet, about 3 meters. You want to show the area that is, sorry, about 5 meters. You want to show the area that is 15 feet in elevation and below. In order to make this calculation, you must use a more complex tool than the times tool. You will be using a raster calculator. The raster calculator allows you to build and execute complex map algebra expressions. So let's find the tool. Go ahead and click on the Analysis tab, Tools, and do a search for raster calculator. And you're going to see, uh-oh, there are two. Well, we want the spatial analyst one, not image analyst. So choose raster calculator, spatial analyst. And then you can either type in what you see here, or you can double click the layer. So elevation underscore feet is less than or equal to. Again, you can type it in, or you just scroll down until you see less than or equal to, and then enter 15. So elevation in feet, less than or equal to 15 feet in this case. For our output layer, we will call it FLD, as I would actually have spelled it out if this were my lab, but the book says FLD LAND, floodland. And then go ahead and run. So essentially what it's doing is separating out, it's reclassifying all of those numerical values from either, are they less than or equal to 15? The number is representing 15 feet in this case. Is it less than or equal to 15 or greater than 15? So it's a binary yes or no. So if it's less than 15, it is given a value of 1. If it is not less, it's not actually over. If not less than or equal to 15, it gets a numerical value of 0 in this case. And actually this works out well because it gave green to the land side and it gave blue to the water side. When I first ran this lab, it switched it, and so it looked like the land and the water were opposite. So this is actually handy. But I think it is random, so just so you know, you should definitely change the colors in case you do have a situation where the land and the water don't seem to make sense. You just click on the Symbology tab, and then you can change the color there and just do something that makes sense. And while I have this open, I'll also make this match the textbook. So for 0, we're going to call it not flooded. And for 1, we're going to call it flooded. Okay. All right. So let's turn off elevation feet because we don't need that layer anymore. We have floodlands turned on. And now we're going to move on to determining the type of land cover, okay? So now that you've identified which land is flooded, right, you must determine the type of land cover for the flooded area. So was it urban? Was it rural? Was it residential? Was it commercial? Whatever, you know? So the land cover used in this exercise has been classified from Landsat imagery, which means these are satellite images that have been classified. And essentially there are really complicated algorithms that can recognize certain spectral signatures, which is basically the light that gets reflected off the Earth and sensed by image sensors. It can then translate that spectral signature to a land classification type. It can say, this is grasslands, this is arboreal forest, these are palm trees, this is sand, this is dirt, whatever, concrete. All right, so this has already been done for you, so you don't have to worry about it. But it is an interesting looking layer. So let's turn off floodlands for now, and let's scroll down, and I'm going to collapse these two and turn on land cover. And you can see that's what the classification looks like. From up here, it kind of looks like gobbledygook, but if you zoom in, you kind of can start to make sense of things, right? You can see that's probably an airfield, maybe an airport. We can see like roads, or more or less, I guess you'd say concrete or tarmac is red or dark red. More rural areas are probably yellow or green. So you can make out what the urban landscape is versus the kind of outside the urban landscape out here to the north. Okay. All right. So land cover turned on. You can open up the attribute table just to kind of get an idea of what these represent. You don't actually have a name. You just have a value. Okay. So even though I can tell you that based off the book that value 11 represents water, there's no field in here that says water. Okay. So that's one of the downsides of raster data, is it just cuts it down to the bare minimum. What is that numerical value? And you see another field here, count. So not only does it tell you what the unique value is, it also tells you how many cells, how many pixels have that value. Okay, so if 11 equals water, there are over 4.1 million cells that represent water. Makes sense, right? Because it's right there along the coast. So you can close that. And this is actually where I'm going to leave you because I want you to be able to do the rest of this on your own. And just follow the Canvas instructions for deliverables for what I actually want turned in. But I will tell you, you do not need to go beyond the point of classifying the data and coming up with the reclassifying in the domains field. Essentially, I don't expect you to create and publish an editable service online. So you don't have to do any of the ArcGIS Online stuff. You don't have to use Collector. So just so you know, once you get to page 82, finish page 82, do not proceed beyond 82. Don't go on to page 83. Okay. All right. And that's that. Okay. So have a good one. Talk to you later.